Hello guys, my name is Balkrishna Shrivastava and welcome to Code with BK. So in this video, solve the entire paper of ISC 2024 Computer Science Boards paper. So before we begin, it is a request to please subscribe to my channel, because out of 100 viewers, only 3 of you are subscribed, and a subscription is very important. So please do subscribe to my channel. The first things first, please make sure that you check the links in the description of this video, because links for all answers, all codes will be provided in the description of this video. Okay. Also, I will be solving the same problem in Hindi as well. So if you are better comfortable with Hindi, अगर आपको हिंदी में ज़्यादा comfortable है, so you can find the video of the link of the Hindi solution link in the description of this video as well. So make sure that you check the description, right? Okay. So the first question is, you have to find the dual of this equation. All right. So what we do is, this is given as, okay, this is the equation, right? So when you are finding a dual, you have to convert all pluses to dots, all dots to pluses, all ones to zeros, and all zeros to 1. Okay, so when you do this, you get a dot b bar. Okay, the variables and the complements, they remain the same, plus, okay, instead of dot, a dot 0 plus becomes dot 1 becomes 0 is equals to a dot b bar. Okay, so now that we see the options, a dot b bar plus a dot 0 is equal to a dot b bar. This is your answer. Okay, moving on to question 2. When a series of or, not, nor are connected in a series, the logic gate would be or. Okay, so for example, you have two inputs, so this is going to be your or gate. Okay, a b, a plus b. Okay, then you have a not attached to it in series, so this becomes a plus b whole bar. Okay, and then in the series attached a NOR gate. So if you have p and q, okay, going to a NOR gate, okay, this is going to be p plus q whole bar. Okay, so NOR gate is going to be, they get the same input. Okay, in the NOR gate. Okay, so if p and q are the same, okay, so p plus q whole bar, and p and q are same, will become p plus p whole bar, which is basically p bar. Okay, so this goes as p, right? So it becomes a plus b whole bar is basically becomes a plus b. Okay, and so the answer is your or. Okay, next is identity percent law says that a is the first answer. Okay, next is for proposition this, contrapositive with this. Okay, now in this case, assertion is false, reasoning is true. I'll tell you why. So if given proposition is p implies q, okay, so converse is going to be q implies p. Okay, and inverse of this is going to be minus p, not p implies not q. Okay, contra positive is, okay, not q implies not p. Okay, so this is the proposition, this is the converse, this is the inverse, this is the contrapositive. Okay, we are given minus a implies b, minus a implies b. Okay, so we have to say if contrapositive is this, so for this contrapositive is this, so for this contrapositive is going to be minus b implies minus of minus a, which is equal to minus b implies a. Okay, which is not equal to this, so this is going to be, okay, wrong. Okay, now reason is given as contrapositive is the converse of inverse of any proposition. So converse of inverse, so this is the inverse, and when you find the converse of this, okay, so basically you switch, you say this is equal to converse of this, okay, will be equal to minus q, that is not q implies not p, which is equal to the contrapositive. Okay, moving on, the complement of Boolean expression p bar dot q plus r bar dot s. Okay, so p bar dot q, okay, and you have plus r bar dot s, r bar dot s bar. Okay, and you have to find the complement. So basically you have to find the whole complement of this. So this is basically a plus b bar, a plus b bar equal to a bar dot b bar. So a, which is equal to p bar dot q bar dot r dot s bar bar. Okay, now this is a bar dot b bar. Now you can think of this as a dot b whole bar, which is equal to a bar, okay, plus b bar, okay, dot a bar plus b bar, okay, which is equal to p plus q bar, okay, dot r bar plus s. Okay, so this is the complement of this is going to be p plus q bar r bar plus s, p plus q bar into r bar plus s. Okay, next is recursive data structure follows LIFO principle. Execution of recursive code follows the concept of data structure queue. Okay, now this is a little confusing. I mean, recursive data structure, they are saying what does it follow? What is the principle does it follow? I mean, we have stack that follows last in first out. Okay, so you can relate that call to recursive function is basically creating a stack of function calls. Okay, and that is how you can conclude that this is going to be true. Okay, so if this is true, this is going to be false because LIFO is not a principle of Q. So in this case, assertion is true, but the reasoning is false. Okay. Next is one of the uses of interfaces in Java. It is used to achieve abstraction. It is used to achieve multiple inheritance. Okay, you can write any one of those. Okay. Moving on, cardinal form of max term. Okay, so this is going to be uppercase M. Cardinal form is going to be this is 0, this is 1, this is 0. Okay, so this is 2, so this is going to be M2. Okay, this is done. Then we have write canonical SOP for FAB. Okay, this. Now A implies B and B implies A. Okay, for A comma B. Okay, so if I do 0 0 1 1 0 1 0 1. Okay, so this is true. It means if A, if and only if B. Okay, this basically the truth table comes out to be when they both are equal, then the output is 1. Okay, otherwise output is 0. Okay, so the truth table is going to be this. So canonical SOP is going to be, this is going to be A bar dot B bar. Okay, and this is going to be AB. Okay, so canonical SOP is going to be A bar dot B bar plus AB. Okay, and this is the answer for this question. Okay, one difference is instance variable and class variable. So instance variable basically all objects get a separate copy of an instance variable, whereas class variable is common to all objects of the class. Or you can say that changes made to class variable are reflected back to all the objects of the class. Changes made to instance variable are not reflected to all the objects of the class. These both statements almost mean the same. Or you can say instance variable are only created when an object is created. Class variable is already created in even when there is no object created. Okay. Moving to question 2, convert the following to postfix. Okay. So I am going to take this equation. Okay, so you can follow the stack method, but I have a shorter way to do this. So for anything which is given as left, OP and right, this is to convert to postfix, right? So I am going to change any form like this to L R OP. Okay, where L and R are variables and OP is an operator, right? So I am going to start with the one which is going to be executed the first, which is this bracket, and within this is going to be done first because it's multiplication. Okay, so this basically is P plus, okay, Q into R. So I change is this to QR into, okay, and this is one term minus S. Okay, writing the rest of them. Okay, then, okay, this is one term. Now you have to solve this bracket first. So P plus this term minus S, right? Now what will happen first is the left one. This P plus is going to happen first because the precedence of plus and minus is the same and you go from left to right. Okay, so this is basically L in this case, this is R in this case, and this plus is the OP. Okay, so we do LR OP, so we do left, which is right, then this is QR ampersand, and OP, which is plus. Okay, so this is one term and you do minus S to it and still in the brackets, minus T into U. Okay, now this is L, okay, this is OP and this is R. Okay, we do L R OP again, we do L, which is P Q R into plus, okay, R is S, OP is minus, okay, and this is your bracket, okay, bracket minus slash T into U. Okay, then we move on. Okay, now this is gone, this is going tilted. I'm sorry, I don't know why this is going tilted. Okay, this is one variable, this bracket is one variable now. Okay, it will evaluate to one value. Then we have slash T into U. Now what will happen first is slash and then into, because slash and into, slash and asterisk, they both have the same precedence, again left to right. So this will happen first. So this is going to be L, slash is going to be OP, and T is going to be R. So you do L OP R, you do P Q R into plus S minus T slash Okay, this becomes a variable. Okay, this is becomes a variable and we do into u. Okay, moving on, this has to be calculated to the same L R O P. So L is P Q R into plus S minus T slash U into. Okay, this is your answer. Okay, so this is done. Okay, next is this question. So in this you have to find the address of this location, and row measure wise is the way in which this 2D array is stored. Okay, now I've already added a separate video that explains exactly how this works, and then we have a formula that comes out of that explanation on which we are going to just plug in the values. Okay, so formula in this case is basically you have base address, okay, plus, okay, you have in this case we have number of rows as 15 minus 5 plus 1, which is 21, number of columns as 11. Okay, so columns are 11 and rows are 21. Okay, so the formula is BA is equals to number of columns into R minus R naught, okay, plus C minus C naught, okay, into size. Okay, we plug in this formula, okay, and we get the address of this. Okay, so we can say A D D. Okay, so we have to find this, all these values are given. So base address is basically 2500, this is 2500, plus number of columns is 11, okay, into R minus R naught. Now R is the row that you have to find, which is 10. Okay, so 10 minus R naught is minus 5, the first row. Okay, all right, plus C minus C naught. C is 15. Okay, C naught is this, the first column, which is 10. Okay, into this entire thing into size, which is equal to 2. Okay, so this is equal to 2500 plus, okay, 11 into, this is 10 plus 5, 15 plus 5 into 2 is equal to this is going to be 165 plus 5 into 2. Okay, so 170 into 2 equal to 340. Okay, so this comes out to be 2500 plus 340, so 2840 is your answer. Okay, all right. Okay, now the other way you can do this is, example I can give you is, let me go to, okay, this. Okay, now imagine this is your 2D array, the way it is stored. Okay, what I'm trying to say is we have, this is your, we have 21 rows, right? So this is minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, minus 5 to 15, right? These are your rows and your columns are from 10 to 20. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Okay, you are here. Okay, the base address here is 2500. Okay, and you have to find the address of 10, 15, which is basically 10th row, which is here, this row, and 15, which is here. Okay, so you have to find the address of this. Okay, so you have to travel basically all these cells before this. Okay, so you have to travel this block, which is basically this block. Okay, this entire block. Okay, now this is going to be equal to these many rows into number of columns. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, 15 rows into 11 is going to give you again 165. Okay, 165 cells you have traveled, and then these 5 again, okay, to reach here. So plus 5. Okay, so 170 cells you have to traverse from here in order to reach here. Okay, now 170 into 2, okay, will give you the address you have traveled, which is 340. So that's how you add 200 plus 340, you get 2840. Okay, all right. So moving on, this is done. Moving on to this. Okay, Now what will be the output of Jolly? I will just simply give you output because you can run this on code, right? So output is going to be 7. Okay, and what is it performing? It is finding the largest. Okay, so this is done. Okay, moving on. uh, the following function is part of some class. Okay, now this question is a little tricky because I feel this should be a percent symbol. Okay, they have given into 10. Now I was not able to find any way where I could use this multiplication sign and then get the right output, okay, of the smallest digit. Okay, so this is okay, that this is going to be n percent 10 because you start with the first digit n percent 10. Okay, so this is supposed to be n percent 10. So what you can do is simply replace this by n. Okay, and you should be getting the marks. That's what I feel, because this is a typo. Okay, if you simply do n, and here you do, if r, you have to find the minimum, right? So this is a ternary operator. So if r is greater than minimum, we find minimum. Okay, else we find r. Okay, so for 1 you have to do n percent 10, for 2 you have to do n, and for 3 you have to do. Okay, they should get you marks. Okay, moving on to question 3. Okay, so equation x equal to, so basically your equation x, okay, in this case comes out to be x equal to, what does it come out to be? Candidate must be a postgraduate, so p. Okay, should either possess a BA degree or a teaching experience, so either possess a. Okay, so basically this is has two options. BA degree is basically B, or this is B. Okay, or, okay, it says or in the first option, teaching experience, which is E. Okay, and then you have or for the next statement. Okay, must be of the same college with a teaching experience of more than 15 years, same college, teaching experience of more than 50 years, so SE, plus S and E, plus must be a postgraduate, so P. Okay, not an employee of the same college, so S bar. Okay, and should have a teaching experience more than a year, so E. Okay, so when you expand, it basically becomes PB plus PE plus SE plus P bar SE, and that's what I'm here finding out in the table. Okay, so basically you can write is equal to P. Okay, all right, so this is going to be an equation. Then what you have to do is draw a trip table for input and give the SOP. So this is going to be your trip table. Okay, I've already made it because it's going to be a tedious task, and your SOP is going to be this. Okay, all right, so we have 6, 7, 9, 10, 11, 12, 13, 14, 15 terms as 1. Okay, now when you draw, the next part is going to be reducing by Karnaugh map. Okay, so Karnaugh map, you have 6, 7, which is 6, 7, 9, 10, 11, 13, 14, 15. So I get 3 quads. Okay, one quad is 7, 6, 15, 14. Okay, which is this SE. One quad is 15, 14, 11, 10, which is this. Another quad is 13, 15, 9, 11, which is this. Okay, this is your reduced expression, and this is your logic circuit. Okay, moving on, you have question 4 first part. Question 4 first part I've also done here, right? Okay, question 4 first part had to reduce this Boolean function 0 to 4, 6, 8, 9, 10, 11, 14. So okay, this is how it comes out to be. You have 3 quads again. Okay, so this is the first quad, this purple one, this blue is another quad, this red thing is another quad. Okay, all right, so reduced expression comes out to be this, and then you have the logic circuit. Okay, next part is you verify this is a tautology contradiction, or you're using a truth table. So what you have to do is you have to create a truth table. Now this is the truth table that I've created. Okay, you have 3 variables here, right? A, B and C. Okay, so this is a truth table. This is A implies B, this is B implies C, this is the intersection. Okay, and then I have A implies C. So this entire thing basically means that this is considered P, this is considered Q, and this is P implies Q. Okay, right, this you consider this whole thing as P, this whole thing as Q. Then finally you have all the rows as true, which means it is a tautology. Okay, this is a tautology. So contradiction would be if all the rows are false. Contingency would be some rows are false, some rows are true. Okay, so this is done as well, and this is a tautology. Okay, Moving on, find the complement of p dot p plus q dot q dot. Okay, so I have to find the complement. Okay, so basically, okay, and you have to reduce it by Boolean loss. Okay, so I have to find the whole complement of this thing. Okay, so I'm going to consider this as a and this as b. Okay, so a dot b whole bar is going to be a bar plus b bar. So p plus q whole bar plus, so q into q plus r bar. Okay, whole bar. Okay, now this is again a dot b whole bar, so a bar plus p plus q whole bar plus again a dot b whole bar is a bar plus q plus r bar whole bar. Okay, okay, p bar plus, okay, p plus q whole bar is a plus b whole bar is p bar q bar. Okay, plus q bar, q plus r bar is going to be q bar dot r bar. Okay, plus q bar and r bar cancels, so q bar dot r. Okay, so we can take out p bar as common, so p bar you have 1 plus q bar. Okay, plus q bar 1 plus r. Okay, now 1 plus any variable is going to give you 1. Okay, so this comes out to be 1. So p bar dot 1 is p bar plus q bar, so your answer is going to be p bar plus q bar. Okay, so in order to verify this, what you can do is you can solve this. You can say this is p dot p plus q, okay, into q plus r bar. Okay, so p goes inside, it becomes p dot p, which is p plus pq. Okay, then q goes inside, q dot q is q plus, okay, qr bar. Okay, again p plus pq we can think as p 1 plus q. Okay, this entire thing into q, okay, 1 plus r bar, 1 plus r bar. Okay, this is 1, this is 1, so this becomes pq. Okay, so this equation which was given, which is equal to pq, now when you do whole bar, it becomes p dot q whole bar, which is p bar plus q bar, which is the answer that we got. Okay, so this is going to be, okay. Okay, next is, so this is done. How is the decoder different from a multiplexer? So decoder is used to decode data, multiplexer is used to transfer data. Draw the logic circuit. So I have the logic circuit, let me show you. So this is how your decoder is supposed to look. Okay, you have 3 inputs which is going to 8 outputs. Okay, so draw the logic diagram for 2 input OR gate. Okay, so basically what you can do is you can take A, okay, into a NAND gate. It is basically A dot A whole bar. Okay, A, then you can take B, okay, this is B dot B whole bar. Okay, put it to another NAND gate. Okay, so A dot A whole bar, okay, dot B whole bar. Okay, so A dot B whole bar is P dot Q whole bar is into P bar plus Q bar. So A dot A whole bar plus B dot B whole bar. So this is going to cancel. A dot A plus B dot B is going to give you A plus B. Okay, alright, so this is your gate. Moving on, this is done. Okay, write the kernel terms for M3 and M5. Okay, 3 is for 4 variables, 3 is going to be, okay, and for this 5 is basically 1, 4 plus 1, 5, right? Okay, this is a max term, right? This is a min term. So max term is going to be A, okay, and this is your question 5. Okay, alright, so this was part 1, and all the remaining questions apart from this from the next section are already solved and uploaded, so you can check out the link of the video in the description, right? The solutions for all those are already added. Okay, so I hope you like this video and it was helpful. So please let me know in the comments your thoughts about this video. And you can also let me know in the comments if there is a question you want to solve or if there is a concept you want to discuss. Thank you.